Download this code from codegive.com, link in the description below. Removing broken links with the Fetch API, a comprehensive guide. Broken links, also known as dead links or link rot, are a common problem on websites. They lead to a frustrating user experience, can negatively impact your SEO, and make your website appear outdated and poorly maintained. Identifying and removing these links is a crucial part of website upkeep. While there are many tools available for this purpose, this tutorial will focus on how to use the Fetch API, combined with JavaScript, to identify broken links programmatically and, optionally, remove them from your HTML dynamically. This approach offers a flexible and customizable solution that can be integrated directly into your website management workflow. Why use the Fetch API for link checking? Programmatic control. The Fetch API gives you fine-grained control over HTTP requests, allowing you to inspect response headers and status codes for each link. Customization. You can tailor the process to fit your specific needs, such as handling different types of links, implementing retry logic, or integrating with a content management system, CMS. Client-side or server-side. The Fetch API, with appropriate polyfills for older browsers, can be used both in the browser, client-side, and in node.js, server-side, making it versatile for various applications. No external dependencies. Mostly the Fetch API is a built-in browser feature, and available in node.js since version 18. While older browsers may require a polyfill, it reduces the need for third-party libraries for basic functionality. Workflow and key concepts. Here's a breakdown of the process and the concepts we'll cover. 1. Identify links in your HTML. Use JavaScript to select all A elements, or other elements containing links, like img tags if you're checking image sources. 2. Send HTTP requests using Fetch * for each identified link. Use the Fetch API to send an HTTP head request to the link's target URL. A head request is preferred because it only retrieves the headers, not the full content, making it more efficient. 3. Analyze response status codes. Examine the HTTP status code returned in the response. A status code of 200, OK, indicates a successful request. Status codes like 404, not found, 500, internal server error, or timeouts generally indicate a broken link. 4. Handle redirects. Some links might redirect to different URLs. You'll need to handle redirects to check the final destination status code. 5. Report or remove broken links. Based on the analysis, you can report the broken links, example log them to the console, display them in a UI, or send them to a server, or dynamically remove them from the HTML. 6. Handle CORS. Cross-origin resource sharing. Be aware of CORS issues when checking links that point to different domains than your website. This often requires a server-side solution or configuring CORS headers on the target server. Implementation with code examples. Let's create a function that identifies and checks links on a web page. This example focuses on client-side JavaScript running in the browser. Explanation. 1. Check links, function *. This async function handles the entire link checking process. The async keyword allows us to use a wait for cleaner asynchronous code. 2. Document.query selector all, A, *. Selects all A, anchor, elements on the page and stores them in the links variable. You can adjust this selector to target other elements containing links, example img src. 3. 4. Of loop *. Iterates through each link element. 4. Fetch, ref, method, head, mode, CORS, *. Fetch, ref, asterisk initiates an HTTP request to the link's URL, href. Method, head, mode, CORS asterisk configures the request. Method, head asterisk specifies that we only want the headers, not the content of the page. This is more efficient. Mode, CORS asterisk sets the request's mode to CORS. This is crucial for cross-origin requests, requests to different domains. You may still encounter CORS issues if the target server doesn't allow your origin. In many cases you will need a server-side proxy or appropriate CORS headers on the remote site. 5. Await response.ok asterisk. Response.ok is a Boolean property of the response object. It's true if the status code is in the 200 to 299 range, successful. Await pauses the execution of the function until the fetch promise resolves, i.e., the request completes. 6. Error handling, try, catch. The try, catch block handles potential errors during the fetch request, such as network errors or invalid URLs. 7. Broken links.push, asterisk. If a link is determined to be broken, based on the status code or an error, information about the link, the element, the URL, and the status code or error, is added to the broken links array. 8. Reporting/removal, example. The code demonstrates how to log the broken links to the console using console.log, broken links found, broken links. Add a CSS class, broken link, to the broken links, allowing you to style them, example make them red with a strike through. 9. Event listener asterisk. A button with the ID check links button is created. When it's clicked it will trigger the check links function. Important considerations and enhancements. Asterisk CORS, cross-origin resource sharing. The problem asterisk if you're checking links that point to domains different from your website's domain, you'll likely run into CORS issues. Browsers enforce CORS to prevent malicious scripts from accessing data from other domains without permission. Solutions asterisk. Server-side proxy asterisk. The most reliable solution is to create a server-side proxy. Your JavaScript code sends requests to your server, which then forwards the requests to the target URLs. Your server can then relay the responses back to the client, bypassing CORS restrictions. CORS headers on target server asterisk. If you have control over the target server, you can configure them to send appropriate CORS headers, example access control allow origin, asterisk or access control allow origin, yourdomain.com. However, this is not always possible. JSON, not recommended. JSON is an older technique for cross-domain communication that involves wrapping the response in a JavaScript function call. It's less secure than CORS and only supports GET requests. Avoid using JSON unless you have a very specific reason. Asterisk rate limiting asterisk. The problem asterisk sending too many requests to a server in a short period of time can be considered abusive and lead to your IP address being blocked. Solutions asterisk. Implement a delay asterisk. Introduce a small delay, example 200 to 500 milliseconds, between each fetch request. This prevents overwhelming the server. Use set timeout or a similar mechanism to implement the delay. Queuing asterisk. Queue the links to be checked and process them in batches with a delay between batches. Respect robots.txt asterisk. Always check the robots.txt file on the target server to see if there are any restrictions on crawling or accessing specific URLs. Asterisk retry logic asterisk. The problem asterisk. Temporary network glitches or server issues can cause false positives, i.e., incorrectly identifying a valid link as broken. Solutions asterisk. Retry failed requests * implement a retry mechanism that automatically retries failed requests a certain number of times before marking a link as broken. Use exponential backoff, increasing the delay between retries, to avoid overwhelming the server. Handling redirects *. The problem * links may redirect to other URLs. You need to check the final destination of the redirect chain. Solutions * response.redirected * the response.redirected property, part of the fetch API, indicates whether the response is the result of a redirect. Response.url * if response.redirected is true, the response.url property contains the final URL after the redirect. You can then check the status code of that final URL. Asynchronous processing The problem checking a large number of links synchronously, one after another, can block the main thread of the browser, making the page unresponsive. Solutions promise.all use promise.all to check multiple links concurrently. This can significantly speed up the process. However, be mindful of rate limiting, as sending too many concurrent requests can overwhelm the server. User interface, UI. Instead of just logging to the console, create a more user-friendly interface to display the broken links, allowing users to easily review and fix them. Provide options to remove broken links automatically or to edit the links. Integration with CMS If your website uses a CMS, integrate the broken link checker into the CMS workflow, making it easier to maintain link integrity. You might create a CMS plugin or module that automates the link checking process. Regular expressions for URL validation You can use regular expressions to validate the URL format before sending the fetch request. This can help prevent errors caused by malformed URLs. Logging Implement detailed logging to track the link checking process, including successful and failed requests, errors, and any actions taken. This can be helpful for debugging and monitoring. Complete example, with redirect handling and rate limiting. This example incorporates redirect handling and rate limiting for a more robust solution. Explanation of the complete example delay_ms constant * defines the delay between requests in milliseconds. Check link function * handles the fetch request and error handling for a single link, encapsulating the core logic. Process links with delay function * this asynchronous function iterates through the links, checking them one by one, and introducing a delay between each request using setTimeout and a promise. This implements rate limiting. Promise.resolve setTimeout turns the setTimeout function into a promise that can be awaited. CSS styling * the example includes CSS styling to visually indicate broken links. Server-side implementation, node.js. Here's a basic example of how you might implement this on the server side using node.js and the node fetch library. Since the built-in fetch isn't available in older node.js versions without a flag, node fetch is a more portable solution. This example assumes you have a file named links.txt containing a list of URLs to check, one URL per line. To run this * 1. Install node fetch * npm install node fetch. 2. Create links.txt * create a file named links.txt with one URL per line. 3. Run the script * node your script name.js. Summary. This tutorial has provided a comprehensive guide to removing broken links using the Fetch API. By understanding the concepts and code examples presented here, you can build a customized solution for identifying and managing broken links on your website. Remember to address core issues, implement rate limiting, and consider retry logic for a more robust and reliable solution. Good luck.